Okay, so let's get started. So continuing from the last session, in the last session we talked about the partitioning and bucketing. What are the advantages we can perform, and how this is specific to Hive. In today's session, we will discuss more things which are specific to Hive, and how they help us to achieve customizations as well as to help resolve various other issues. Now today we will discuss few more things about Hive. We will also discuss about UDFs, and it is very much similar to the one in Pig. We had created a UDF there. We also talk about how to connect to Hive using a Java program, and we'll see few more things which are not covered in our syllabus in our dashboard, but I think we should know, and so I will be sharing those information about Hive also. So first of all, we couldn't complete on that day. This is the thing, how to create a particular bucketed table. So this was the property which has to be set to true. It is by default false. This ensures that bucketing is enabled, and then we can overwrite into the bucketed table, and then if we can see to the HDFS, there will be number of files which equals to the number of buckets we had created. So this is how we create a table with some particular buckets, and this is how we insert data into the buckets. We can check the files of bucketed table also. And if we want to fetch a particular data of only particular bucket, then this is the table sample. This is the query which is used to take the output which belongs to the data of a particular bucket of a particular table. Okay, so these things are there. One thing I must tell is one more optimization which is there in Hive and which is not there in SQL. But before that, let me give you the problem statement and how it helps. Suppose we have got a table. This is our Hive table, and it has got some records. We have got one more Hive table, and again it has got some records. Suppose this is the users table and this is the logs table. So the user will be, suppose user ID is 101, name is ABC, user ID is 102, name is PQR, and so on. Similarly, logs is user ID hi. Logs can contain a particular user ID multiple times, hello. Then 101 is hi. Then 103 is fine. These kind of things are there. I want my information. I want in those. I want information from left table. This is my left table. This is my right table. So I want information from left table. That is, I want ID and I want name. Only these two fields. I can get it from a users table. But the condition is this ID must exist in the logs table. That is where this ID exists in the logs table. So this is a situation. Now this forces us to join these two tables. So any idea how to write a query in this case? Suppose we are having two tables. One is users, and let the alias be u, and we will perform left outer join, or we can perform an inner join logs L. The condition is on u.id is equal to L.id. Okay, and we will fetch u.id and we will fetch u.name. So this will give us the desired output what we are looking for. So we will get the user ID and username from the users table, and where if since it is joined on with logs on the basis of ID, so those ID which exist in users table as well as logs table, they will only appear in the output of this particular uh, projection, that is this particular columns. So this is one way it will work, no problem. But there is, let us see how we can optimize the things in Hive. If we try to do inner join, this, if you remember, this particular record, it contains 101 as the user ID. It will first, it will be compared with this record, it will be then compared with this record, it will be then compared with this record, it will then be compared with this record. So similarly, one record of this particular table will be compared against n records, like it is all the records of logs, because there is inner join. But see, what we are taking, we are not taking anything from logs table, we are just detecting the presence. So how things will be if we compare this particular record of users table with the records of logs, and as soon as we get 101 as the entry in logs table, we should stop searching forward, that is stop searching, because it doesn't matter that 101 has got one record in logs or 100 records. We are just searching for the presence, it is present or not. So as soon as we get the first record, stop searching forward. Similarly, for 102, it will scan the first, 102 is not found. It will scan the second, 102 is not found. So similarly, as soon as 102 is found in any of the records, suppose 102 is here, it will not search forward. Now this is an optimization in these use cases where we search for the presence of a particular column in the other table. So there are some use cases where we can exclude inner join, and in that cases we use something called as left semi join. So this semi join concept is not there in RDBMS, but it is there in Hive. So the use case is it will stop searching for the scanning the other rows in the right side table once a matching entry is found. So instead of inner join here, it will be great if we could simply instead of inner join here, we could write it left semi join. So this is one optimization with left semi join. So if you know this, this will be beneficial in some use cases. Any doubt with this? Yeah, while using left semi join, you cannot take anything from the right table because it is just detecting the presence. So this is the left table users, this is the right table logs. So you cannot have anything from the logs table in the output if you use left semi join. So it is suitable for few use cases. Now I'll talk something more about file formats and SURDE before we go into other things. So I mean, I'm a little surprised that if we are discussing about Hive, maybe in future we will incorporate these few topics in our syllabus also. As of now, it is not a part of our Hive syllabus, but it is very, very compulsory that you should know this. Maybe in future we will incorporate, but as of now it is not there, but we should know. So let us talk about the file formats and SURDE. This is very important topic of Hive. I guess we all know what is a SURDE. SURDE means serialization and deserialization. Serialization means how an object is converted into bytes, and deserialization means how bytes are converted back to objects. So let us talk about file formats. What happens is, suppose if we have got the first file format which is very, very common, it is called text file format or text input format kind of. So text input format, what is there is, suppose you have got a few records, that is say employee ID and employee name. This is there. I'm taking a very simple example. So suppose there are few records. So let us take these three examples. So what happens, it is stored in the file in this in this way: 101 comma Ahmed, and then there will be \n. Then there will be other record which is 102 comma Rashmi. then there again will be \n, then there will be other records. So this is how things are stored actually in the file. So this \n might not be visible. It looks like a new line, but internally it is stored in this way. This is usually called as the row format. So every line, suppose this is the first record, record 1. This is the second record, record 2. This is the third record, record 3. One way is very much efficient, that is called columnar format. And what happens in columnar format is all the columns are stored sequentially, then all the rows are stored, then all the other rows are stored. So what do I mean by this? If I store this in a columnar way, it will look like something like this. All the values of a column will come to a row. That is, suppose the table contains only 3 rows. The table may contain multiple rows, but let us consider. Then this particular column, all the values will come together at in a particular line. Then there will be \n, and then there will be the records for the other column. So this is the second column. All the records will come like this. Amit, Rashmi, and Lakhya. So what this has, it has got two advantages as compared to this particular. This is a traditional format. So as compared to this format, our new format, this new format has got two major advantage. The first advantage is, you can very well see, this was the first record. So one record may contain of multiple data types. You can check this out. This is integer. You can see this is a string. So one record may contain multiple data types. But here you can see all those values are of the same data type. All of them are integer. And they must be same because they belong to a same column. So one column has got one data type. So they are all integers. Similarly, here all together are strings. So what happens is, if we have got similar data types placed one after the other, then it leads to better compression. So the compression of the file is better if all the data of same type are placed one after other. So which was not there initially. The second advantage is, like, suppose there are, in this example, there are two columns. Suppose I want to fetch only the ID column. I don't want to fetch the name column. So this is my example. And what happens in practice is, your Hive tables may have hundreds of columns. It is a possibility. It can have hundreds of columns depending upon the size and the variety of data. So let us take an example of two columns first. So I don't want all the columns. I just want only a particular column. I want only the ID column. So I can just sequentially read this thing before \n. If I try to read only this part sequentially, it will give me the result. Whereas what happened initially, I have to read the whole record, all the 3 records to get the, because I will read the first, then I will extract 101, then I will read \n, I will read the next record, I will extract 102, I will read next record, I will extract 103. So I have to read all those things and extract our relevant portion. But here what I need is there already sequentially. If I need to read only the name, if I just need to read only the name, I will skip the first \n because I have the information, like name is the second column. I will read this portion sequentially. So the queries which do not select all the columns, but the queries which select only few columns, that is what I told, we have got hundreds of columns and we need only 5 or 6 columns, for example, in our queries. Then instead of scanning through all the columns, we will just fetch all the concurrent values of these columns. So selective columns, if we use those queries, it will be faster in this columnar format. So there is one file format which is called RC file format. RC file format stands for a row columnar file format. So the way I told about how it is represented, a row columnar file format stores data. It first splits data into horizontally, and then it column wise it stores data. That is just to give you a little more example, for huge data set, for example, if we have got a file and this file contains sorry, so suppose we have got a file and it contains large number of records. Suppose it contains some thousands or millions or billions maybe of records. So a single file will not be able to store this. So what happens in row columnar format is a portion of file is taken. This is the first portion, this is the second portion. Corresponding to this first portion, we create a columnar data, like this will contain column 1 data, then backslash n, then column 2 data separated by space or by comma, then column 3 data, then column 4 data, so on. This is like that. Suppose it has got 4 columns. Similarly, for this also, a new file will be created which will contain the column data. So it first splits the file horizontally, and for every split, it will do the columnar arrangement. So this is called RC file. So whenever we want to create a particular RC file in Hive, in the very end, we can use simply a stored as RC file. So if while creating a table, we use this particular clause, then that table will contain data stored as RC file format. So let us try to take a demo on this. So what I'm doing is, the syntax looks like something like this. So I'm creating a table. The name of table is emp_rc. These are the various columns or various fields of the table, and I have included stored as RC file. So this will create a table, and the table will be stored contain the RC file format data. Now if I try to create say show tables, so I will be able to see. So emp_rc already exists, so I'll drop the table. I'll drop table in emp_rc. So the table has been deleted. And if I try to paste this to create a table, now I have created a table, and I'm trying to load something. So first of all, let's see what is there in emp details. So emp details table looks like this. Oh, sorry, emp details is not found. Okay, so let's see what is there in any existing table. Let's check emp_p, select a star. So these are the things. So this looks like name, which is the emp name. Then there is unit is okay, experience and location. Okay, so what I'll do is I'll try to modify this query a bit. So I'll insert override table emp_rc, which is RC file format table. And what I'll do is the emp_rc has got the schema of emp name, then unit, then experience, and then location. So I'll select these things. Select emp name. Okay, just a second. Let me check the schema of emp_p, because from this table we are going to load into our new table. So it contains name, exp, location. Okay. Select name. What else do we need? We need name, unit, experience, location. Name, unit, experience, location from emp_p. So what happens is this, if you remember this emp_p, it is a text file input format table. So it was loaded from a text file. So it has that kind of a structure. So Hive will automatically do the file conversions. So that is, this table contains text files, but this table should contain the RC file. So conversion of text file to RC file, it will be done internally by Hive. So we need not to bother about that. We just need to specify what is going to be the input and output formats. So it has been loaded, and let's see the content of emp_rc. Select star from emp_rc. So you can see that data has been correctly loaded. Now one more thing I like to show you. If I try to see the actual file of emp_rc, but before that, you can see The input format is the RC file input format. The output format of the table is the RC file output format. So RC file is the row columnar file, and this is the location of the table. I'm going there and I'll check what is the how the files look like. So I'll do one thing. I'll DFS minus ls. I'll paste this out. So you see this is the file present in this directory. Okay, let me try to read this file. Let me see what happens if I try to read the file. So see, this file is something which is not readable. It is something which is not readable. But one thing, if you just try to see, all the string values are together. You can see this. If you try to see this, there is some internal delimiter, that is control A, so that delimiter might not be visible to us, but you can see all the like Anil, Amit, Mihir. What is this? This is the all the values of the column name which were there in different records with different rows. They have been together in a single record. So this is the advantage of RC file. So though we are not able to view this properly because of the encoding it has, and if you try to see this part also, string part, the BNG, Bangalore, BBSR, so all those things, all those values which belong to a particular column, they have been collected together. So this is how RC file behaves. An optimized version of RC file format is called ORC file format. So that is also an optimized version. So in ORC file format, that is optimized record columnar file format, it is an advanced version of RC file format. And this gives us better compression, as well as querying against ORC and RC file formats is faster in many of the cases. So is this file format clear?
What is the use case where we use RC file format?
Yeah, the first thing is the compression is very good as in RC file format. So instead of using the text file format, if you use an
okay.
Sorry. So yeah, one thing is there.
Can you please go to the terminal? You executed right now. If here, if you will see, I have seen somewhere it was saying compression 0. No. Compressed, no.
Okay. Yeah. Right. Yeah. So here it has not been compressed, but you can choose a compression also.
Okay. So okay. So if I will choose compression, then only RC file format will compress the files.
Yeah, right. What happens is by default it compresses the file, and you can specify the compression in the table properties also. While defining a table, there is a last field called as table properties. So if you want to specify a few other configurations regarding the table, you can specify there. So you can choose a compression.
You have told us that for columnar format also compression is better. So I feel for RC it would be more better.
Exactly, right. So for RC and ORC file formats, the compression is good.
Only this is the reason behind for choosing these type of formats?
Yeah, this is one of right. So this is one of the reason, and the other reason is we just discussed some time back. So if there are queries where we are not fetching all the columns in a single shot, we are fetching a subset of columns, then in that situation also the columnar file performs better, because
that is for formula. For RC I was asking.
Yeah, RC is also a type of columnar format.
Okay.
Yeah, RC is a type of columnar format. So this is this is, if you want only this column, then it will be fetched very soon.
Okay, Amit.
Yeah. So recently there is a component, RDBMS component called as, HP. HP is a company who has developed a Vertica. This is a kind of columnar RDBMS, and it is it is taking up the market by very much good impression that it is much faster than Oracle. And underlying architecture of this Vertica is also, it is a columnar RDBMS. So all the columns are stored together.
So we are using this as a database.
This Vertica?
Vertica.
Yeah,
What is
Vertica is it is a database. It is not open source. It will charge the license, but it is
okay?
faster than Oracle.
Okay, and it is using columnar format.
Exactly, exactly. The
Oh,
underlying file format is followable.
thank you.
Lakshya, is this clear?
Yes.
Okay, that's great. So this is one file format. Now the second thing is, let's talk about SERDES. I believe you all have basic idea of SERDES, the serialization and deserialization. So what happens in SERDES is, suppose I have got a requirement that some identity has been, a file contains some identity, and identity is of the format of name, and then there is domain, and name, sorry, name, and then there is some instance. So this is some instance at the rate domain. So for example, it could be, I'll show you the file. For example, it could be like okay, so it could be something like this. This is the host one. Sorry. Okay, so role, there is role, then there is name, and then there is domain. So we have got some file like this. Oh, my mistake. It's not like that. Okay. Suppose it is something like a role, then there is slash, then there is name, and then there is a domain. So we have got files like this. So for example, it could be admin, it could be Rashmi, it could be at the rate, domain could be your company name, maybe Google or whatever is the company name. Similarly, it could be user one. So there is some file which contains this format. So it could be anything. It could be Amit, it could be Facebook, anything. So what happens is, I want, so the file contains a structure kind of this. So I want to select out the, separate out the fields. Like you can see, this is the first field, this is the second field, and this is the third field. But the problem is, the delimiter is not of a single type. You can see the delimiter is of two types. In a single file, delimiter is of two types. And there could be multiple delimiters as well. What happens in the log file, if you can see the log file, they contain the timestamp first. So then there is this timestamp. Then they will contain some space. Then they will contain message, then they will contain maybe colon, then they will contain username, then they will may contain at the rate machine name. So there is something like, there is a, I mean, there are data contains information, but it is delimited by varieties of delimiters. But what is common factor is, it follows a pattern. So if I have to write it, this line in a regular expression, it could be something like, it is dot star. Dot star means any sequence of characters. Then there is slash. Then again there is dot star. Then there is at the rate. And then there again is dot star. So this is one regular expression. Dot star means any sequence of characters. You will see any sequence of characters, then a slash. Then any sequence of characters, then at the rate. So I want to fetch this particular dot star, this particular dot star, and this particular dot star. So this is going to be my field 1, this is going to be my field 2, and this is going to be my field 3. So how to do these kinds of things in Hive? So Hive has got something called as a regex SERDE. Regex SERDE means a SERDE for handling the regular expressions. Let us see how to create that and how to use that. So in a simple table, I have created a table called as user log, and this table is going to contain this file. Okay, this is the host, this is the role, this is the name, username, this is the domain. So I have created these three are the strings. You will see in the SERDE, I have specified the regex SERDE. I'm going to use regex SERDE. And what are the SERDE properties? My input regex is going to be of this particular format. This is something we discussed. Dot star, then slash, then dot star, then at the rate, then dot star. We must specify these things in bracket, because the things which you specify in the bracket, they will be considered as fields. And what do I want in the output? Like whenever I want the output from this table, I want, this is the expression for selecting the first field, this is for second field, and this is for the third field. So I want the first field, then second field, and then third field. As of now, we cannot use int, double, any other things with regex survey. We have to use only string. So $1 percentage $1 s means the first string, this means the second, and this means the third. Let us try to do the hands-on with this and see how it behaves. So first of all, I'll show tables. So you will see the regex user log table exists. Okay, let me drop this table. So I will drop the table user log. So it has been dropped, and I will recreate the table using this. And I have got a file whose name is regex file. I am trying to load that file into my table. That particular file is in my local file system, and I believe you all know how to load a file from a local file system. Okay, regex file is not here perhaps. Okay, let me check where is it. Regex file. So regex file is here. It should have been here. Okay. Okay, so it has been loaded. Now if I try to do select star from user log, you will see these three fields are getting displayed independently. Now if you want to display the header also, then the syntax is set.hive.cli.print.header is equal to true. If you use this, then your header will also be displayed. You can see the header is displayed, the column name. So this is the first column name, this is the second column name, this is the third column name, and this is the output values. So this is the way we work with surveys. Now there is a difference between file format and survey. Survey will help you identify how to encode or decode a particular record in a file. Like for example, the file which we used, it was a text file, but how the fields are going to be treated, it is determined by the survey, and how the content of file is going to be written, that is determined by the input format. So if you use RC file format, then your records will be internally, it will be stored in a different way. But when you are retrieving the record, how you want the records to be manipulated, that is described by the survey. So they are connected, but they are different. I mean, they serve different purpose. Yeah. Any queries on this regex survey?
Amit?
Yeah.
In this regex survey, do we use complex regular expression also?
Yeah, we can
Means
use.
like date or something like that? Or
Exactly.
always like this?
No, dot star is a simple case. You can use any other complex expressions also, not a problem.
Okay.
So this is one more important thing about okay. So there is one more thing which is called windowing functions, and I am tempted to discuss on these. They are called analytic functions, or they are called window functions or windowing functions. So these functions were there in Oracle and other MySQL database or other RDBMS databases for a long time. They got added to Hive few months, few years back, some 1 or 2 years back. So what do they do and what are the powers they have? So this is something which is important. Which in Hive, there have been few use cases in Hive which have advanced over time. For example, inserting a row level insert or a row level delete, these things are not possible in Hive. They were not possible earlier. And Hive does not support updation. So it's like it's a basic kind of warehousing technique. So you have got file, you do not want to write the MapReduce program, you want to write the Java, you don't want to write the Java program, you just want to write a SQL query to perform the analysis. Then Hive is a very, very powerful tool. It is of great use in most of the many organizations, but it is not suitable for your, it is not a database. That is, in a database you can insert any record, you can retrieve any record, you can delete any record. So it is not suitable for your real-time processing. It is for batch processing. So some queries which will take longer time, if you want to process large amount of data, maybe of the scale of petabytes, then it is a very, very good tool. It's a very fantastic tool for that. But for some, depending upon use case, Hive is not suited for that. But there have been few advances in Hive in recent time. One of the important advancement was the transactions. So uh, the transactions in Hive, they have been added. And the one important thing is the execution engine. So Tez is basically a Hindi word. Tez means anything which is fast. So what happens is, underlying the Hive, it calls the MapReduce job. So MapReduce is the execution engine. And the one more execution engine of Hive has been Tez. So Tez is in many ways it is faster than MapReduce, and this is again one advancement of Hive in the recent days. So these are the two things which, if you want to read, you can go ahead and you can explore these things. These are the new changes in Hive, and along with these analytic functions also, they have also been incorporated into Hive to extend its functionality. So we'll try to see analytic functions in brief, maybe by the end of this session. But for some time, let us discuss two more important use case of Hive, that is how to access Hive using Java program, and how to write the UDF in Hive. Then we may come back to analytic functions. So before we start, I've got a Java program which is there. And before I proceed forward, I must share a few things, like just like we have got RC file format, we have got ORC file format, and there are some other file formats as well. The text file is the default one. There is one file format called sequence file, which I have discussed in the past, like sequence files contain binary files. And there is a paraquet file also, avro file is also. So these are the various file formats, and they have their own sets of merits and use cases. But this ORC file format, this is widely used. So this is kind of extension of RC file format. So using accessing Hive from a Java program is very, very easy. So I have called that a thrift Hive queries. So I've created a class Hive queries, and then there is a main method where the execution begins. So first of all, I need a driver. So driver is used to make connection with the Hive. So just like a JDBC driver, just like you make a connection with any other database from your Java program, you can connect, you can make a connection to the Hive tables and Hive databases. So this is the driver which is used, and then the syntax is very, very simple. First of all, what do we need? We need a connection object and we need a statement object. So connection object is used to create connection to the Hive, and this statement object is used to execute a particular set of statements. So this is my connection object. So the default port, this is the machine name. The machine name is localhost because I'm running on my local machine. If the machine is different, we will give the IP address of that machine of the network. And this is the name of the port. So Hive listens on port 10,000 by default. And this is the name of the database. So we are connected to the default database. For our Hive, the username is Acadgild and password is blank. Then statement object is there. So my table name is test Hive driver table 1. So this table, if it exists, then I will drop the table and I will create a table, Hive test driver table 1, with these two columns, key and value. But before that, there is a service called as Hive, Hive thrift. Okay, let's try to run this and see what happens. If I try to run the program, if I try to see the console, you will see I get an error called as connection refused, because Hive is not accepting Java connections or connection from other programs. So Hive is not it is not accepting the connections. So what happens is Hive has got a service which is called Hive thrift. So if you want to connect Hive to with an external program, maybe Java program or in any other program, Hive thrift must be running on this particular 10,000 port of the machine. So how to run this? So we have to start the Hive thrift. And in order to start the Hive thrift, just a second, the syntax is, just a second. Let me find out the syntax for that. Syntax to start the Hive thrift is okay. So I'll share this. I'll share this program to you also so that you can work on this. Yeah. So this is it. So in order to this, your all MySQL should be running. Your other Hive services should be running, and this service, Hive server 2, this must be running. So in order to start this, I'll type this command in the terminal to launch this. This will start the Hive server to accept connections from external programs. So you will see it will get started in a minute. Okay. So it has started. Now if I try to run the program, but before I try to run the program, let me check a few things. Okay, so this is my Hive default database, show tables. You will see this Hive test driver table is existing. Let me drop this table. So I have dropped this table. Now if I try to show tables, this Hive test driver table is not present. Now if I go to the program and if I try to run the program, let me comment these portions as of now. I'll come back to these portions in a while. Now if I try to run this, in the console it will try to connect and then it will execute the statements. If I go to the Hive again and if I try to see show tables, you will see this table got created. If I try to see the structure of the table, I will use describe and then I will write the table name. And it has got two columns. One is key and one is value. Key is of int type and value is of string type. So the program has completed and it has created a table with key as int and value as string. So this is how you create a table. Now, if you want to fetch the records from existing tables, so this is the syntax for that. First of all, I need to write the query. Suppose I want to run this query, select star from the table name. One way is I can go to the Hive and I can fire this query and whatever is the result. So these are the records. These are the results which I obtain. So this is the query. This is something which will print on the screen. So result set is a class which is used to collect the output of a query. So this res object, it will collect the output of this query, and the objects, the content of this result set can be accessed using get string or get int, whatever is this. So what happens is all these records will go to res. So I will loop through all the records of res. I will print this part. This is the first part of every record. this is the second part, this is the third part, this and this is the fourth part. We can see the first, second and fourth part are of string types, and the third part is of int type. So that is the reason why I have used get string 1, get string 2, get int 3. That is the third object is of integer type, and the get string 4. So I'm trying to display all those things separated by tab. So if I try to run this command, run the program, so I'll save this. In the output, you can see this query is running, and these are the outputs I received. So I have not launched, I have not gone to the Hive CLI, that is command line interface. With the help of a Java program also, I'm able to connect to the Hive, and I can run my DDL, that is table creation, table deletion, or we can run the DML, that is how to select queries, and we can perform our Hive actions. So these are called Hive clients. So one client which we saw was the Hive CLI. That is, you usually go to the command line and fire the query and get the result. And one client is your Java client also, or you can see, you can also call this as a JDBC client, because it uses JDBC, that is Java Database Connectivity Model, to connect to Hive and give us back the result. So it's very much simple to use. So you can connect to Hive using your program also. The only criteria is this thing must be running, that is called as Hive service. You can see there are many OKs. OK means the output of Hive. Whenever you do creation of table or drop of table, if the query runs fine, it gives us OK as the output. Like if you go to Hive terminal, you will see if you use this query, select star from this, it will give OK. That is a kind of a message, like whether the query succeeded or it failed. If I use something like this, then it will not give me OK, because the table does not exist. So this OK is a kind of message which represents whether the query succeeded or failed. So on the terminal where your server is running, for Hive server 2 is running, you will get lots of OKs for every query which is fired in the Hive from the external programs. Okay. Anything to ask on this, like how to connect to Hive using external programs?
Amit,
Yeah.
can you show us that what are the external jars you have included in this project?
Okay, so for this to run, there are lots of jars which are required, because this is a Java program I'm trying to run on the same machine where Hive server is running. So I've not created the jar, I have not used that. So we
Okay.
need to include these kinds of jars for our project. So I'll share this file with you. It contains all the list of jars which have to be added for the program.
Okay. Okay. Okay.
And these are the locations also, like in my machine, this jar was at this location. If you are using the same sandbox, this jar will be accessible to in your machine also at the same location.
Okay.
So Lakhya, is this clear?
Yes.
Okay, that's just fine. Now I have to write a UDF. We all know what a UDF is. In the pig, we have seen that in order to extend the functionality, there are many functions which are there in Hive. That is count, sum, average, concatenation function. There are many functions. And if you want to add your own customization, that is, you want to create a function which does not exist in Hive and you want to use that, very much similar to whatever we used in the pig. So we can use the that particular utility of Hive also. We can create a custom UDF, that is user defined functions. So just to recollect what happened in the pig, we used to, whenever we were in a situation to write our own function or create our own function, we first of all, if you remember, we used a class called as eval_func. We used to extend that eval_func. Then there was a method called as execute. So okay, I have the program with me. I'll show you. In the pig UDF, this was a thing which we used. This is something which we have used. So there's a class called eval_func. You extend that class. Then there is exec method. Whatever is the content of this exec method, that is executed, and it always takes tuple as the input, and we can proceed with that. And then what happened, we used to create a jar, then we should go inside the pig, then we have to register the jar, then we have to, if we want, we can use our own alias for the class, and we use the class name to execute our own set of programs, our own set of function. In the Hive, it is very much similar, but there are a few differences. Let us see what are the differences. First of all, you have to extend the UDF class. So UDF, you have to extend the UDF class, and this to upper is my own class name, and you have to override the method called as evaluate. So whatever is the content of evaluate method, you will be displaying that. And in my case, it is a very simple functionality. I'm taking a string as an input. And that if input is null, then I will return a null. If the input is not null, I will simply uh, make it to the uppercase. That is, I will change the case. If it is a lowercase, I will make it uppercase, or whatever be the case, the final output will be uppercase. But if I try to give two inputs to this particular function, then this method will be called. This is called overloading, which we all know. So we are having the same function name. The function name cannot be changed. It has to be the evaluate, but the number or type of inputs may be different. So if we are having two inputs, if both of them are null, then null will be returned, else both will be converted to the uppercase and separated by comma. So this is my, suppose this is my use case. So how to use this? I will be first of all creating a jar of this. So if I go there, right click, if I go there, you know how to create a jar. So I will create a jar, and then I will go to next. I will choose the name of the jar and whatever is the name. So suppose this is a hive udf.jar. So I'm not creating this jar because I have already created this. I'll show you where the jar is. So you can see this hive udf.jar is present here. So if you go to Hive, how to use this, let us see that. Okay, let me exit from this here first. Let me clear the screen, and where am I? Okay, so I'll go to cd hive ls minus lrt. You will see hive udf.jar is here. So I will go to Hive. So the syntax is slightly different. In pig, we use a register jar. Here we will use add jar. So it will look like something like this. I will use add jar. Then what is the jar we want to add? So it is hive.udf.jar. So it will say like it has been added. Then we will use we can access the function of the jar by using the class name also. Okay, let me show you. What was that? Show tables. So let me check what is the content of select star from bucketed underscore emp. So these are the things. Okay, and if I try to describe this particular table to see what are the names of the fields, so emp name is there, unit is there, many things are there. So I'll fire the query select. What was the name of my class is to upper. It is inside the package udf. So I will access this class name. I will write a udf dot to upper. So this is the class name which contains the overridden functionality of evaluate. So whatever is the evaluate code inside evaluate, that will be executed. So I'll show you. This is how we can access, and emp underscore name from bucketed emp.
Amit, that command is not visible. Can you move it up?
Okay.
Yes, yes.
Just a second. Oh, want me to move it up? Okay.
It's okay. Now
That's
it's
right.
okay. Yes.
So I'm passing the column name. So all the values of this column will go to this particular method one by one. If I try to launch this, invalid function. Okay. So what we can do is we can create a temporary function. Say, let us call it as custom underscore to upper as whatever is the name of the class which contains the evaluate method. So it is to upper. So now whatever is the evaluate function inside this particular class can be accessed using this function. So instead of using this method, we can use custom underscore to upper. Yeah, it looks fine. So you will see all the employee names are now in the uppercase. If you do not use this method, if you just try to select the EMP name, they will come in the order they were. Like if one is in lowercase, it will come to lowercase word. So you can see this is the original case. Now this is the all in uppercase. And if you try to see something like, if you try to pass 2 arguments, it should work well with that also. If you find to unit, so now it will convert both to the uppercase and it will return a string which is separated by comma. So you can see this, it will return a string separated by comma, both converted to the uppercase. Whereas if you wouldn't have used this particular function, then you would have received a slightly different output. So you could have received this as output. So this is how my that particular program is behaving. So this is because of the logic which has been written in the function. So in this way, we can extend the functionality of Hive by using, we can integrate our own code. Yeah.
Amit, you
Yeah.
showed that it is separated by comma. This is the
Yeah.
default separator in this case?
No. See, here we have used the comma as a separator.
Okay.
The default separator is the tab. It is a tab.
Okay, Amit. I have not seen the code.
Okay, no problem. So this was all for the day, but we have not completed yet. We have much more things to discuss, and I hope things are clear. If they are not clear, we can discuss. There is no hurry. And
Amit,
yeah.
I have one question. Like
Yeah.
page, we used to use filtered UDF for Boolean values.
Yeah, right.
So here also we have, or always we should override evaluate method.
Yeah, so here there is a single class called as UDF. There is nothing called eval func or filter UDF. There is, I mean, pig has got that distinction. But here also we can, if you want to do some filter activity, instead of returning a string, we can return a boolean.
So
Okay,
we
so we can,
have feasibility.
yeah, exactly. We can return a boolean also. So that will return either true or false, and then we can use that particular in the where clause.
Okay. Okay, thank you, ma'am.
Okay. Yeah. Any further questions? Lakhya, you there? Oh, okay, Lakhya.
I don't have right now.
Okay, so I'll be sharing these files and these codes so that you can practice on your own. And these are very, very important things. So if you have been able to understand this, so far we have been able to discuss about Hive, we have been able to discuss about Pig, we have been able to discuss about Hadoop, MapReduce, advances in that. If you have not gone through the things like any assignments or any videos or any, I have shared additional assignments also time to time. So these are very, very important concepts. If you know at least these 3 things, getting a job in big data industry is very much comfortable. But we have to discuss one more important tool, and that tool is called HBase, which will start from the next session. That is a kind of database. So it's like it's a it comes under the category of NoSQL database. So what exactly is a NoSQL database and how HBase is different from RDBMS? That is also very good important concept. But and we will be discussing that in depth. So 4.5 hours will be spent only on HBase. That is 3 sessions for HBase. We will be discussing how HBase works, what is the architecture of HBase, and that will start from the next session. We'll also talk about how to communicate with HBase using a Java API. and that will also boost your skill set further. But it is very much important for us also to keep on ingesting and understanding the things on a regular basis. And needless to say that whatever we have discussed till now we have discussed kind of about 70% of the syllabus we have completed. More than that, if we, because the last 4 sessions are going to be the project one, so we will be handling this HBase, and we will be discussing Spook also in the future. So we have got few more things to learn. That's very good. But we have completed a greater length of our journey. So please keep on revising on a frequent basis, because if you won't revise, then it becomes difficult to retain things for a longer time. So these things will certainly help you if you want to extend your service in the current organization, or if you want to go ahead with the other organizations. In my current organization itself, I am currently in Bhubaneswar, so they are conducting a kind of a drive for Hadoop developers only for Bhubaneswar location in the month of June. And yeah, and if you want to go ahead with the career in big data, you can show your experience as 2 years kind of, because the things which which you have taken from the sessions, if you have honestly completed the assignments, and if you have gone through the videos and lectures and all those things, you can compete successfully, truly successfully with any 2 years experience Hadoop professional, and or 2 years or more. But yes, we need to have a few important things. Like the most frequent question which is asked is, tell us something about your project. So we need to know few more use cases of Hadoop and Hive, so that you can build your story around that. Like what are the use cases, in which scenarios it can be used, and how. Like for example, uh, like Rashmi just asked me some minutes back, like what are the use case of RC file. So you can discuss in the interviews also, like we had a requirement where we were using the text file, so because of better compression and more efficient query resolution, we switched over to RC file. Later on we also moved to the ORC file. So they might ask you, like why do you think this RC file is better than text file, and why you moved from a text file to RC file. So you can talk more on that. And so these are the things. And yeah, uh, we have got time. So if you are not in a hurry, we can discuss one more thing. So can we discuss one more thing?
Yeah, yeah.
Yes.
Yeah. So one more thing is, oh sorry, I by mistake I stopped my share. Yeah. The one more thing I would like to discuss is the analytic functions in Hive. These analytic functions were there in Oracle for a longer time, and if you want to know more about analytic functions, you may, I'll show you. Suppose if you want to go to this analytic functions, you can in Hive. Okay, I'll show you how it works and how it behaves. So this is one language manual which is there in the Hive official website. So this manual is okay. By the time it gets opened, so there's one more good site, good link for this Cloudera blog or Cloudera documentation, but they're not much up to the mark. Okay, so I'll come to this. What exactly is this, and how the syntax works, and how it behaves. But before that, I would like to ask a question. Now, see what my question is. You can compute advanced functionalities with this, but the question is, and these questions they are getting popular day by day. I mean, for because these have been added recently in Hive, so these things are gaining strength as compared to earlier interviews, and this is something which you can expect in your interviews. So the use case is, suppose we have got a data file, and the data file contains the name of the employee, the salary of the employee, okay, and then there is a rating of the employee. Okay, so similarly we have got this. Okay, let me add it. Okay, like this. And we have got Lakya. Please don't mind, I am using a very low figure for this salary. And Lakya is there. So Lakya is having somewhere in middle, and he is having a rating of 1. Okay, so something like that. Okay, and let us also use the technology, like in which, what is the unit. So it is big data, it is C++, okay, it is Android. Okay, now, so similarly we have got such data in the files. Okay, so instead of here we can write any other name. Here we can write any other name, like okay, suppose Smita is not here, but maybe. Now the question is, we have seen how the data looks, and I'm adding one additional lines for clarity. Okay, so this is my data. Now I want to know this thing in the output. I wish to know, like what is the name of the employee. Suppose it is the name of employee is Amit. What is the salary of the employee? Suppose it is 10,000. And I want to know what is the mean salary. That is, what is the mean salary of his unit. That is, if Amit belongs to big data unit, you can easily see Amit is there, Sumit is there, Mukul is there. There are 3 employees who belong to big data. So the first employee, the salary is 10,000. For second employee, for Sumit, the salary is 12,000. And the third employee, Mukul, the salary is 8,000. So these are the salaries of his unit. That means the unit to which he belongs. If you add up these things, it turns out to be 30,000. Okay, so there are 3 employees. It means the average is 10,000. So I want the mean salary. Similarly, I want this for all. That is, I want this for all the employees. I want this for Rashmi. That is, the salary of Rashmi is something like this. And Rashmi belongs to C++. His unit is, her unit is different. For C++, the average salary is, you can see from here, it is 20,000. Then for Sushma, it is 18,000. And one more guy, Rahul, is there. For his, there is 14,000. So here the mean value will be something different. You can see, if you can quickly compute, it will turn out to be 44,000, sorry, 42,000 perhaps. Is it? Sorry, 52,000. My bad. So it will be 52,000 divided by 3. It is, I mean, close to 17,000. Okay, like that. So I want this for every employee. I want this, the mean salary of every employee. One way to do this, which quickly comes to our mind, is if we use this query. Just see this. I want select unit, and I want average of salary from the table. Table is, suppose, EMP table. So we can do this average of salary over the unit, but here we need a group by unit. This is one way to do this. So what happens is, for every distinct units, That is, in our case, if you use this query, then this will belong to, say, first group. This will also belong to first group, and this will also belong to the first group of same unit. This will belong to the second group, this will belong to second group, and this will belong to second group. So for every group you can take the average salary, but you cannot take the name here, because if you specify name here, you have to specify the name here also in the group by clause. So this is a restriction with the group by. And if you specify name here, then one particular name and one particular unit, they will be considered to be in one group. So you won't be able to take the average of the whole group, of the whole unit. So this is one scenario. The other scenario is, I may also be interested who is the second highest in terms of salary in every unit. That is, if we talk about big data, in this example, it looks like Amit is the second highest. So I want this result. Similarly, if I talked about C++, it looks like Sushma is the second highest in terms of salary. Similarly, for every unit, there is a second highest. How to calculate those complex situations? So these they come under the category of analytic functions. What happens with analytic functions is, we first create a partition. So whenever we specify a partition, our data gets divided into windows. That is, if I create a partition on unit, if I create a partition on unit, you can see unit is my field of the column. So there will be a window created for big data. So big data window will contain 3 results, because all the results of big data will come to one partition. Okay, and all the results of big data. Similarly, this is one window. Similarly, one window will be created for all the employees of C++. All the records, because C++ belongs to three employees. Similarly, for or what are the different values of units, Android is also one of them. So it will be created. And on every window, you can compute anything you want. You can create, if you want to take the average of this window, you can take the average of this window. You want to take average of this window, you can take this, and for this. So you can take average for every window, and that average can be in the output, that particular average will come for every employee. The syntax looks like this. You have to partition by on the basis of certain column on the basis of which you want to partition. Then you can perform a sum operation, average operation, or just like we discussed about how to take the second highest. Okay, so we can perform, like, average is one of the operations. You can perform these things also. How to take the second highest, third highest, all those things if you want to take that. So we can also perform that. So let us see how to do that in this situation. So suppose let us talk about select star from emp_rc. Let us take this file. So we have to fetch the this is the experience perhaps. Okay, so we have to fetch the average experience for every unit. So what we'll do is select, just a second, _rc. So it will be emp name unit, like that. Okay, so I will select emp name, and then I will select average of experience. That is, what is the average experience in his unit. Average. Okay, I'll also talk about the experience and average experience. Here we have to specify, just if you can see the syntax. Here we will be specifying the partition, like over which partition. Okay, so here we'll specify, sorry, over partition by unit. So for every unit, so this will give me for every unit what is the average of the experience of the employees in that unit. Okay, so equal to the number. Okay, so that is just a second. So that is a good. Yes. Okay, just a second, let me check it out. I've not specified the table name. This is not required. So table name was missing out there. That's silly mistake. Okay, so it will work. We'll check. So there is also a condition of rows, like which row. This we will talk later. So you will see this will give me the name of the employee, the experience of the employee, and what is the average experience of employees in the same unit in which the particular employee works. So like you can see for Amit, the experience is 1, but the average experience of the employees in his unit is 2. Similarly, for others, you can see there could be some different values also. So this is how things can work on this. Now, just I told you how to take the second highest value. So, okay, is this clear? Is this concept clear? Like what is the window and how to operate on this? How to use partition by?
The concept is clear, but
Yeah.
I am not able to get the command. Maybe you can share it by mail. I will check it.
Okay. So like here we have taken the partition on the unit. So it is like, and for every unit, in my example, in the last example, we were taking the average of experience. So we will use select whatever columns you want, like name, age, whatever. Then I want for every employee the average of experience in the example which we show. So average of experience on which window? So over, I will specify the window partition by.
Okay.
This will help us to unit. So based on every distinct values of unit, a window will be created, like one window for this unit, one window for this, and one window for this. On every window, you can calculate the average of experience or average of anything which you want. Average of salary, average of anything. So this is one important utility which is there in which has been added to Hive. It was earlier there in other RDBMS, but not in Hive. Now it has been sorry. Now it has been added in Hive also. So please take this as an additional assignment, like how to fetch the second highest salary for every group, for every unit. Like who is the one who gets the second highest. So these things can be asked in varieties of ways, like we have got an e-commerce website, and that contains the category of a product and what is the number of sales of that particular product. So if you may be asked, like which is the category in which comes as the third highest in number of sales, or which is the category which comes as a second highest or fourth highest. So these are the things. Okay, so in Hive, the most important questions we have discussed all. You won't be able to miss any questions from Hive in any interview or Hadoop or Pig, anything. But these things are also very much important.